Hello everyone. So in this video I'm going to talk a little bit about meshing, what it is, why it's important, and also talk a little bit about why computer analysis is extremely beneficial. So for any type of analysis, there are certain equations that have to be solved. For our case with fluid flow, there's 4 different equations that have to be solved simultaneously. Equations like something like this. These equations are calculus-based equations, and they're very complex. It would take a computer hundreds, maybe even thousands of years in order to solve. So smart people have figured out a way to estimate these equations into algebraic expressions. The main difference between these calculus equations and the algebraic expressions is the calculus equations will solve the whatever you're looking for, temperature, velocity, whatever, at every single location within the domain. So you would be able to figure out what the velocity or temperature is at every single point. The algebraic expressions, on the other hand, only solve it at a certain location at one specific time. So in order to use these algebraic expressions, you have to break up the domain into a bunch of points. Breaking up these breaking up the domain into these points is what is called meshing. So this is what a mesh would look like. This is our grid. So the algebraic expressions would solve the equations at each one of these points all at the same time. So if we're talking about temperature, then it would solve the temperature at each one of these locations. The things with these algebraic expressions, since they're from calculus, and the calculus expressions solve the equation at, or solve whatever you're looking for at the whole domain, the algebraic expressions uses every single point to solve for one point. So what I mean by this is it's a system of equations that all have to be solved at the same time. So if you break your grid into a million different points, that means that the equations have to be solved at a million different points at the exact same time. So there are disadvantages and advantages about the number of points you have in your domain. If you have a lot of points in your domain, it's going to be very accurate because if your points are very spread out, you lose a lot of information between each point because we're not solving anything along this line. We're solving it here and we're solving it here. So we don't know what's going on here. We just guess what's going on here, or the computer guesses what's going on. The bad thing about having a lot of points is that it takes the computer a lot longer to solve because you have a lot more equations to solve. Uh, so the computer uses these algebraic expressions to solve these equations at every single location. So why is computer analysis so great? Well, if you first let's think of one equation with one unknown. So an example is y equals 2. That's easy because y can only be 2. Now let's say we have two equations with two unknowns. We can figure out with algebra what it is. With y plus x equals 3, 2y plus x equals 5. If you're taking algebra, you know how to solve these equations. Now imagine that there's 3 equations, and now there's 4 equations, and now there are 5 equations. Well, for the typical situation, there involves 1 million nodes and there's 4 equations. So for 1 million nodes and each node has 4 equations, that's 4 million equations with 4 million unknowns. So that'd be extremely hard to solve by hand, and computer analysis does it extremely fast, and it still has accuracy. And actually what it's doing is not actually solving the system of equations all at once. It actually guesses the answer and then refines its answer after each iteration. And that's a lot faster. So hopefully that made sense to you. If not, feel free to comment or email me. Uh, Meshing was the hardest thing for me to understand when I first did learned analysis. Uh, I didn't know why I was breaking up the grid or breaking up the domain into a grid until someone finally told me. So hopefully this makes sense to you guys that we're breaking the domain into a grid because we're solving algebraic expressions instead of calculus expressions, and the algebraic expressions only solve at one specific point where the calculus equations solve at the whole domain.